Okay guys, so we're going to cover some other types of problems and we're going to finish up the worksheets that I was assigning earlier this week for this type of stuff. So you might want to get out your notes from 6.1 and 6.2 so you don't have to write all this stuff down. You can just kind of fill in the blanks and then you'll have something for your homework you're going to have for this weekend as well. So let's go ahead and jump back to 6.1 first. Right-handed and left-handed sums. On Wednesday we talked about subintervals, right? Here's the type of problem we didn't get to yet, and that's pretty much what we're focusing on today, is problems where they don't give you a graph or a table, but they just give you an equation. So, well, when it comes to that, you pretty much the answer to this question is pretty much you're just going to end up making your own table. All right, so first of all, they want us to do a left-handed Riemann sum with 7 subintervals to estimate this area under the curve. Now, I'm going from -4 to 10, so my last x value is 10. My first x value is -4, and I want to break this up into 7 pieces to find the width of my rectangles, which I'm going to represent with delta x. So that's 14 divided by 7, which is 2. So I'm going by 2's basically. So what I'm going to do then is I'm going to make my own table since they didn't provide me with one. And we're going to go by 2's starting with our lowest x value. My lowest x value is -4. So now we're going to go by 2's because that's the width of the rectangles that they want. So if I go up 2, that's -2. Up 2 again is 0. Up 2 again is 2, up 2, up 2, all the way until we get to the very last x value that they want from us, which is 10. Okay, so let's stop here and make sure you guys know what to do first. This is the harder part, I guess, maybe. If you get this far, you're going to be home free pretty much. So let's start over. What do? Last x value minus first x value divided by the number of subintervals. That's how many. This is the width of each rectangle, and that's what you're going to count by. You start with your lowest x value, and you count by this number until you get up to your last x value. So now what do? Well, now we need to find our y values. Well, that's what this equation is for. So basically, we're just going to be plugging in the x values that they give us. So if you plug in -4 there, you're going to get 0. If you plug in -2, you're going to get the square root of 2. If you plug in 0, you're going to get 2. If you plug in 2, you're going to get the square root of 6, and so on. I don't like these y values either, but we'll make it work. Okay, so there you go. That's your table. So we want to do a left-handed Riemann sum. A left-handed Riemann sum. So when you're doing a left-handed Riemann sum, you're going to find your bases, which we already know is 2. Right? Every base of my rectangle is 2. And by the way, how many rectangles do I have? 1, 2, 3, 4, 5, 6, 7, because that's what we made it, right? So we have bases of 2. And then the heights of these rectangles, when you're doing a left-handed sum, is you're going to start here. So the height of the first rectangle is 0. The height of the next rectangle will be 2. And you're just going to keep doing that until you get to the very last one. And when you get to that last one, we don't use the right endpoint. Remember that? Okay. So here's my area then, using this estimate. 0 times 2 is 0. Radical 2 times 2 is 2 radical 2. 2 times 2 is 4. Radical 6 times 2 is 2 radical 6. And so on. Okay, now I'm just going to kind of treat this FRQ style, honestly, and I'm not going to simplify it. I'm just going to leave my answer like that. I didn't want to have to go through and get a calculator and figure out all the decimals and stuff. So, but there's the idea. So, what do we have to do? Let me refresh this for you guys one more time. Okay. So first of all, the first thing you're going to do is you're going to do your last x value minus your first x value over the number of subintervals you want. And that tells you your delta x. Okay? The next thing you're going to do is you're going to make your table starting with your first x value. I'll put f there for first. And you're going to count by delta x's. So whatever you got for here, that's how far you go up. You just keep doing that over and over again. And you keep going until you get to your last x value. The next thing you're going to do is you're going to find your y values. And you get those by plugging in. After you've done that, business as usual. Just remember what we did back on Tuesday and Wednesday. If you're doing a left-handed sum, you take all the left-handed pieces. If you're doing a right-handed sum, you take all the right-handed pieces. So there's your steps there. So I'm going to go ahead and throw one of these up on the board for you. You guys can see how you do. I would ask you guys to have the sub pause the video here. I would have you guys work on this for about maybe like 4 minutes, we'll say. And then when you unpause the video, I will have the answer with the work displayed. So go ahead and pause the video now. Okay, there you guys go. Last, oops, too far. Last minus first. Alright, going the wrong way. Last minus first would be 6 minus negative 6 divided by 4 subintervals gives me a delta x of 3. So starting at my lowest x value of negative 6 and going up by 3's, we end up with our last x value, which is 6, giving us 4 subintervals of a base of 3. Since this is a right-handed Riemann sum, we're doing 26 times 3, 1 times 3, 10 times 3, and 1 times 3, and we don't include the last negative 26 there. There's the math, and there's our final answer of negative 42, and there we have it. Alright guys, so go ahead and get out your 6.2 notes from yesterday, Thursday, and we'll look at another one here, example 5. Same type of question. They don't give us a table, so we need to create our own, right? So a lot of the beginning steps are going to be the same. There is something kind of different that happens, though, in the middle here whenever you're doing a midpoint sum. So let's go ahead and begin the process. So what would be my last x value? Hopefully you guys know it's 6. What would be my first x value? 0. How many intervals do I want? 3. So we're going by 2's again. So now we're going to make our little table. Matter of fact, I think I'm going to take up a little more space for this table because you'll see something interesting kind of needs to be done here. Alright, so we're going to start at my lowest x value, which is 0, and we're going to go up by 2's. So it's going to be 2, 4, 6, and I think that's it actually. We're supposed to stop at 6, so let me back up a little bit here. Okay, so we have our 3 subintervals with bases of 2. Now, basically, you might be really tempted to go through and find all the y values. You can, but you don't need to do this, and I'll show you why in a minute. But for now, I'm just going to follow the process blindly. If I plug in 0, I'm going to get negative 9. If I plug in 2, I'm going to get negative 5, and so on. 16 take away 9 is 7. 36 take away 9 would be what, 27? All right, so there it is. But here's the thing. We're doing a midpoint sum, right? When you're doing a midpoint sum, here's your, like, consider this. This is our first rectangle here. We're going from 0 to 2, and these represent the heights on the left corner and the right corner, but I really don't want either one of these corners, right? I want to know what's the y value right here in the middle. How do we find that? And so the trick here is a little bit difficult. So what you're going to do is you're going to find what x value is in the middle here. It's 1, right? To find the y value that goes with that, we're going to plug 1 into this function now. If I plug in 1, I get -8. This is the height of the first rectangle. So here's your process. Find the middle x for each pair. Find the middle x. Plug in to find y. Okay? So let's follow those steps again here. So this is going to be my first height and the base that goes with it. This is not the base, remember. This is the middle x that helped me get my height, but the base is still 2. Okay, the width of that rectangle is still 2. All right, let's do the next one. So now for the next one. The next rectangle goes from 2 to 4, right? So there's my next rectangle. I'll highlight that in red there. So the first thing we're going to do is we're going to find the middle x. What's the middle x? The first x is 2. The last one is 4. What's the middle x? The middle x would be 3. The next thing we need to do is we need to plug in to find the y value. So I'm going to plug 3 into this function to find y. Now if you plug in 3 there, you get 0. That's the next rectangle's height. Okay? What I would have you guys do here real quick, we'll kind of treat this one like a guided practice. I want you guys to see if you could find the next rectangle's height. Go ahead and pause the video, take 1 minute, and then unpause the video to check your answer. Okay, so the middle x between 4 and 6 is 5. So if we plug that in, we get 25 take away 9, which would be 36. So here are the 3 heights of our 3 rectangles, and here are the 3 bases of our 3 rectangles. So that's the idea here. So we go height times base plus height times base plus height times base. That goes away. This is 72. This is minus 16. And we end up with, let's see, 62, take away, I don't know. I'm just going to show my work. Don't want to make a boo-boo. 56. Total area, 56. All right. Now, at this point, that's the process, okay? And I think it's important that you guys have, oops, where did my work go? Here we go. I think it's important that you guys have this written down in your notes somewhere, because there's a really common mistake that people make here, okay? Here's the mistake that people make. Let me back up a little bit. So the mistake that people make a lot of the time is they try to find the middle of the y's. Like, what's right in between -9 and -5? Well, it's -7, and they'll call that the height, but that's wrong. That's not how you do it, okay? So don't do that. What you do is you find the middle of the x's and plug that number in to get the right height, okay? So don't find the middle of the y's. That's not how it works. You find the middle of the x's and you plug it in, okay? So having said that, I want you guys practice one of these now. Bring it up for you. There you go. You guys give that a shot. Pause the video. Take about 4 minutes and then unpause the video and the answer will be displayed for you. Alright guys, so here it is. Step 1, finding your delta x. The width of the rectangles is 2. So starting at your lowest value of -4, ending at your highest value of +4, going up by 2's, which are highlighted in pink there. You guys will notice, by the way, that I didn't even bother finding the y values for the x values in my table because they don't matter. The y values that do matter are the y values that go with the middle x's. The middle x's are the green ones you see here, which are -3, -1, 1, and 3. Plugging those in, you get your y values that represent the heights of these midpoint rectangles. So then taking each of these heights and multiplying them by each of these pink bases up here, we get our formula that represents the approximation of the area under the curve, which is 88. So there you have it. One more type of problem before we call it a day. I want to show you guys how to do the same thing with a trapezoid problem. This one probably won't be too mind-blowing, but here we go. We'll do one anyway. Alright, so example 6 on your 6.2 notes. Using a trapezoid sum, estimate the area under the curve for this function using 3 subintervals. So once again, we take the last x value, subtract from it the first x value, and divide by however many subintervals we want. And surprise, it's 2 again. It keeps ending up as 2. I don't know if it's just because I'm not creative, or maybe I just don't want the tables to end up too big, but there you go. We're going by 2's. All right, next thing that we're going to do is we're going to once again make our own table. We're going to start with our lowest x value, and we're going to work our way up by 2's. Until we get to our biggest x value. Which is 3. Once again, you're going to take each of those x values, and this time you do need to plug in these x values into the function. If I plug in -3, I'm going to get 0. If I plug in -1, I'm going to end up with, what would that be? That'd be -8. Plugging in 1 will give me the same thing, I believe. Plugging in 0 would give me -9. And then plugging in 3 will give me 0. Now, for trapezoids, you can either do it directly from the table, or you could do it from a graph. So each of these trapezoids is going to have a height. We call this a height, actually, for trapezoids, a height of 2. And for my first trapezoid, with trapezoids you use both sides. You use the left and the right. So for my first trapezoid, I have a base, or a height of 2, and the y values on the left and right represent the 2 bases. So for my first trapezoid, we have the height, which is 2 over 2, multiplied by the sum of the bases, which are 0 and 8. -8. And we end up with -8. So the first trapezoid has an area of -8. Let's go ahead and take a look at the next one. Here we have, once again, a height of 2 divided by 2, right? You always take the height and divide it by 2. And then the 2 bases for that one are both -8. So that would be -16. My next trapezoid is the next 2 here. So once again, the height is 2. The bases are -8 and -9, which is -17. And then finally, the last trapezoid is going from, my bases are -9 and 0, so we have a base of a height of 2, and my bases are -9 and 0. And then we just have to add all 3 of these up, 4 of these I mean, and we'll have our final answer, which would be 50, -50. Okay? And so I'll let you guys practice one of those. And that should close us out for the day. All right. So go ahead and pause the video, take about 4 minutes once again, see if you guys get the answer, and I'll have the results up for you shortly. Alright guys, so here you go. My delta x this time, the width of the rectangles, is finally different. It's 1. So we're starting at -2 for our lowest x value, and we're going up by 1s until we get to our last x value, which is 2. Plugging those in to get our y values, we see in green here, we get those. The pink represents the height of each trapezoid, and every pair of y values represents the bases of each successive trapezoid. So plugging each one into the formula for the first trapezoid, the bases would be 0 and 3 with a height of 1, and so on for the other trapezoids. Here's the outcome for each one of them. I haven't added them all together yet, but I will now. So adding all those fractions together, 3 plus 7 plus 12 plus 3 is 25 over 2 would be your final answer for the area estimate under the curve using 4 trapezoids on the interval from -2 to 2. And that's it. Happy weekend to you. See you guys Tuesday.